All right, last lesson for sinusoidal, guys. Sorry, doing multiple things. So flip to applications of sinusoidal functions. It's the last lesson in that booklet. And so it says, in the last lesson, we saw that each letter or parameter in the equation corresponded to a particular characteristic of its graph. In this lesson, we will see how each parameter in the graph can help us understand important characteristics of the data. So explore. So I want you guys to actually do the next little chunk. So pause the video once I'm done talking here and give it a try. You're going to look at an example. So it says a Ferris wheel has a radius of 3 meters. So again, when we're talking about something that's circular, the radius is the distance from the center to an edge, and that is 3 meters. So it has a radius of 3 meters and its lowest point is 1 meter above the ground. Sam gets on at the bottom of the Ferris wheel and it takes 60 seconds for Sam to travel from the bottom to the top. It's a pretty slow Ferris wheel, but I guess it'll do. So we'll be examining the relationship between Sam's height above the ground and the time he's on the Ferris wheel. So a couple kind of key things that'll mess you up if you don't get it right from the beginning. So it's saying that the Ferris wheel has a radius of 3 meters. So that's saying if we're in the middle and we draw an arrow anyway, all of those arrows or lines will be 3 meters. It also says its lowest point is 1 meter above the ground. So that represents the little box that he has to stand on to get to the top. So at time 0, Sam's height above the ground is 1 meter. Because again, he's getting on the Ferris wheel here. He's 1 meter off the ground. It says it takes him 60 seconds to go from the bottom to the top. So when he's at the top, so again, the radius is 3 meters. So the diameter of the whole thing would be 6 meters. So his height above the ground is actually 7 meters when he's at the top. Because again, 6 meters for the Ferris wheel plus the 1 meter at the bottom. So your data table, you can fill in the rest of it, but looking at 0, 30, 60, 90, 120, and 150. So fill in the rest of the chart based on that. So kind of think about this drawing as representative of where he would be at each second. So you're going to complete the table of values, you're going to sketch the graph, and then you're going to examine the characteristics of the graph above. So pause this and go through the next 2 and a bit pages until you get to the words guided practice. So you're going to do the regression on it, but do all of those other steps up to that point. So pause this and complete the next kind of 2.5 pages, and then we'll come back and I'll quickly talk through all of it. Okay, so hopefully you've paused and given the whole question a try. If you got stuck anywhere, just move on to the next one, pause it again and keep trying. So sketching the graph of the relationship. So once you've filled out the entirety of the table, so again, at time 0, he was 1 meter. At 30 seconds, he'll be 3 plus 1, so 4 meters. When he's at the top, he was 7. When he gets over here, he's going to be 3, because again, that's the length of a radius, which was 3 plus 1, which is 4, and then it repeats itself. So looking at the graph, again, you're going to do a better job sketching this out. So at time 0, he is 1 meter. 2, 3, 4, 5, 6, 7. So at time 0, he is 1 meter from the ground. If this is 30, 60, 90, 120, 150. So at time 60, he's at 7. At time 30, he's at 4. 90, he's at 4. 120, he's at 1. So just kind of sketching it again, it's a curved line. Got a little weird at the end there, but that should represent our data quite well. So examining the characteristics based on that graph. So the highest point on the curve, so just looking at it, we're not really calculating yet. The highest point on the curve was at 7 meters, and the lowest point on the curve was at 1 meter. We also see that the lowest point on the curve corresponds to the lowest point of a car on the wheel, the Ferris wheel, and the highest point is the highest point of the car on the Ferris wheel. Since the average height of a sine curve is exactly halfway between the maximum height and minimum height, the average height of the curve is 4 meters. So you could draw that onto the car above. So again, the average height is at 4 meters. Your maximum is 7. Your minimum was 1. So again, halfway between, we're going to add those two together. 7 plus 1 divided by 2. That's 4. That's where it comes from if you didn't recognize that right away. So you can draw the median line back onto your curve. Oh. That's the median line. In this situation, we see that the median line represents the average height of the car above the ground, which is 4 meters. Looking at the actual Ferris wheel, the median line corresponds to, I have a question mark on mine, it corresponds to the middle of the Ferris wheel. So if you saw back where I was drawing all those arrows out of the middle, that would be 4 meters off the ground. And part 4 there, it says in the equation y equals a times the sine of bx plus c plus d, the median value corresponds to the letter d. That's from the characteristics that we learned last time. The median value is your d value. Therefore, you can begin to write the equation that models the height of the car. With, instead of d, you have a 4 at the end. So we're starting to write our equation just from our data points. So the period, we know 2 methods to find, oh, sorry, where's my amplitude one? I'm missing a section. Is it below? No, it's not. Sorry, in your notes it'll have amplitude. So it says we know 2 methods to find the amplitude. The distance between the median value and the highest or lowest values of a curve, or the maximum value subtract the minimum value divided by 2. We've usually done A when we've been looking at it before, but both ways will get you there. So it says in either of these methods, the amplitude of the graph is 3 meters. So again, our midline, or our D value, was 4 as we figured in the last question. So it goes 3 units above and 3 units below, 3 meters above and 3 meters below. And so it says, in this situation, the amplitude corresponds to the radius of the Ferris wheel. So part 4 there under amplitude, in the equation, y equals a times the sine of bx plus c plus d. The amplitude corresponds to the letter a. Again, we found that in the last lesson. Therefore, we can add to the equation that models the height of the car on a Ferris wheel as y equals 3 times the sine of bx plus c plus 4. So now, again, amplitude is related to our a. So now we've written more of the equation. So we just need to talk about b and c. So now it says period. The period is the time needed for a sine curve or data to repeat its pattern. The 2 methods to find period are the distance between 2 consecutive maximum or minimum values on the curve, or using the equation, which is on your data sheet if I didn't mention that, period is equal to 2 pi divided by b. In this case, though, we can't use that second method since we do not yet have the full equation to model the data. However, looking at the curve, we see that the period, or the amount of time that it takes for the graph to repeat itself, is every 120 seconds it repeats itself. So remember that it took Sam, is that his name? Sam to go from the bottom to the top 60 seconds. So to go from the bottom all the way around back to the bottom would be 120 seconds. And so that's the amount of time needed for the wheel to complete 1 full revolution. The period is not one of the parameters listed in our equation, but it's related to 1. So b is not equal to the period, but it's very closely related to it. So if we rearrange the equation that we had up here, and we rearranged it to solve for b. So thinking about how we rearrange equations, multiply both sides by p, divide both sides by period, we get this equation. If I'm not mistaken, that's on your data sheet as well. It has both of the things that I've put boxes around there. So b is equal to 2 pi divided by the period. So we can find the b value for our equation by b equals 2 pi divided by 120. So b, again, you can use the pi button on your calculator or just use 3.14. So 2 times 3.14 divided by 120 is equal to 0.0524. So we can further write into our equation here. We already talked about our amplitude, our median value, what's related to our period there that we just figured. So now the only thing that we need to figure out is what our C value would be. And as I mentioned yesterday, usually we're not calculating out the C value. We're just representing whether or not it actually does have a C value. So our starting point, this is related to our horizontal shift. We know that the starting point of a sine curve is the point on the median line, which is also on the upslope of the curve closest to the y-axis. We also know the starting point of the graph that we used several times last time, y equals the sine of x, is the y-axis. So using our graph and the median line you drew on it, determine if the curve has shifted sideways. So if I go back to the curve I drew, right now looking at where we have a starting point. So again, starting point is the median line on the upslope. So it is right here. This is a starting point as well. And we did have another one way back over here somewhere. But what we see is it is actually shifted from our y-axis. So it does have a horizontal shift because that starting point is not right on the y-axis. So all that we can really say with this one is, using your graph, determine if it has shifted sideways. Yes, it has. Therefore, our equation for our curve does have a C value. The actual amount of horizontal shift is affected by both the values of B and C. So that's why we don't actually determine an actual C value. The furthest we can guess is that there is an actual C value. So me saying that doesn't give you a lot of information for what the rest of your actual equation would be. We just know there would be a C value. And yeah, you could sit and try things in your calculator until you got a graph close. But the best way to figure out the full equation is to do an old regression. So flip over to the next slide. It says we can verify our equation by performing a regression on the data we have from the turning wheel. So you've already done a little bit of sinusoidal regression, and again, we did it a lot in polynomials. So what we're going to do in our stat edit, going to put this in y1, this in y2. Oh, sorry, I said y1. L1 and L2, list 1, list 2. And then you're going to perform a regression on the data. So punch all of those in and perform a regression on the data. And so again, if you need to look back at how to perform a regression, you might need to pull out your notes package from polynomials, but you put it in L1 and L2, and then you're using your stat functions to calculate the regression on the data. And so determine the regression equation for the above table of values. So again, make sure you do that in your calculator. Maybe pause it, because I haven't given you enough time, but put it in, perform the regression on the data, and see what you get for your values of A, B, C, and D. And so it says wherever necessary, keep 5 decimal places. I didn't actually do that, I kept 4. So when you perform the regression, y equals 3 times the sine of 0.0524 x minus 1.5708 plus 4. I didn't leave myself enough room. That doesn't look like anything. Plus 4 is our full equation. And so you can compare that back to what we were getting on the last page. We had A is equal to 3, D is equal to 4. We had the same value for B. The only thing that we didn't actually have was this C value here. So our regression allows us to get the full equation. So how did we do? We did great, because we are great. So there's a couple more questions. This is just looking at application. So where we don't actually have just an equation and figuring out pieces of information, but where we're kind of doing word problems to figure out what's happening. So example 1, it says given a scenario and some data. So the table shows the average monthly temperatures for Biggerville after several decades. So looking at the monthly average temperature, so it says perform a regression on the data. So when you're performing a regression, we know when we're entering numbers into L1 and L2, you can't write in January. What you can put in though is month 1. January is month 1. February is month 2. March is month 3, and so on and so on. And then have the corresponding average temperature for the month in your L2. So when you perform the regression, again, pause it, put it in, see what you get. Because again, we're going to do so many regressions. We have 2 more units where we're going to do a whole bunch of regressions, so you better be getting good at this. So the regression equation is y equals 20.6 times the sine of 0.52x minus 2.17 plus 1.32. So that is, I just want to make sure I'm recording. This would be silly if I've been talking this long and not actually recording. Oh, good. I was stressing out there for a second. So the first question, it says the D value is 1.32. So the D value is 1.32 degrees Celsius and represents the D value should be, oh, okay, sorry, I was confusing myself. The average monthly temperature in Biggerville. So that's saying over the course of the entire year, the average temperature, if we look at the entire year, is 1.32, which should make sense if you're looking at it. You have some months that are minus 18, some months that are positive 21. So your average temperature is somewhere around 0, right? And that makes sense with our data. The amplitude of the curve. So again, amplitude is from your median line to your maximum and your median line to your minimum. Again, you're calculating these out. I didn't just pull this from nowhere. What I figured out is my maximum value and my minimum value. This is kind of in a weird order. So looking at question C is where I probably should have gone first, but the maximum temperature for Biggerville should be about 21.9 degrees Celsius. That, again, is from your calculator. You want to trace the maximum. So again, that's where you press second, calculate maximum. You scroll to your left boundary of a maximum. You scroll to your right boundary. You press enter. Jax, you get to do the easy way. You know what you're doing, and you get that data. And the minimum temperature, so again, same idea, you're going to second trace your minimum now. You get negative 19.26 degrees in the winter. So that's where I actually got the value for A. I guess you kind of needed to do question C before you did question A. So once we figure out our maximum and minimum of our graph, we can figure out our amplitude. Oh, I guess, sorry, I'm doing multiple things here. I'm being kind of a goon. You can actually get this from the equation. y equals, I put 20.6, but then I see I did something else, so 20.6 times the sine of 0.52x minus 2.17 plus 1.32. That's where actually all of these came from. So the d value is 1.32. The amplitude, remember amplitude comes from our a value, so the amplitude of our curve is 20.6. I think I have in mind 20.58, so I must have just rounded at some point. So this means the temperature could fluctuate by as much as 20.6 degrees from the median, which is your average monthly temperature. The maximum temperature should be about 21.9. So that's that 1.3 plus, so that's your median line, plus your amplitude, and 1.3 plus, or subtract 20.6. So this is saying my median line plus my amplitude will give me my maximum. My median line subtract my amplitude will give me my minimum. So determine the period to the nearest unit for this data by period is equal to 2 pi divided by b. Our b value comes from our equation, so I had 0.52 as our b value. And so what we get, so 2 pi divided by 0.52 gets 12.08 months. This means the data will repeat its pattern every 12 months. Explain whether or not this sounds reasonable. Yeah, weather patterns repeating every 12 months sounds reasonable to me. If it was more or less, then suddenly there would be snow in July after a couple of years. So yes, weather patterns are periodic in that they kind of follow the same pattern year to year. So the next question, it says determine the mean. So again, the word mean, it means average monthly temperature for February of next year. So February of next year, I don't remember which way I did this, and again, I don't have a calculator with me today. I think what I probably did was when x is equal to 2, because February, month 2, but since it's saying next year, you could actually probably put in month 14, because December is going to be 12, January will be 13, February will be 14. I don't remember what, I think I put in when x is equal to 2, but it should be the same if I put in when x is equal to 14. So again, we're going to look for the value, second trace value, when x is equal to 2, y is equal to negative 17.24. So determine the growing season in Biggerville based on when the mean monthly temperature stays above 7 degrees Celsius. So similar situation in Calgary, right? We can't grow things in January and February because it's too cold, but come May and onwards, it's warm enough to start to be able to grow seeds, but we know when the fall hits, we can't really grow too many plants. Same thing in Biggerville. So what we need to figure out is when in that course of a year is the temperature above 7 degrees Celsius. So what we're actually going to do is you have your equation in y1. So again, your equation is 20.6 times the sine of 0.52x minus 2.17 plus 1.32. And so what we're going to do is in y2, we are going to put in a value of 7 because we want to figure out when it will be above 7. I'll draw kind of a graph to represent that. But we know in this, your graph will look a little bit better than this. So January, it starts real cold. Sorry, I'm losing my mind. But it goes like this. So this would probably be, you know, if this is January, this will be January of the next year. So this will be at 13, I guess. So what we want to figure out is if we do our second line, y2 equals 7, what is this amount of time? So what we want to be figuring out is when does the growing season start? And when does the growing season end? So this is the growing season. And again, that's when it's greater than 7 degrees. So looking at that, we're going to trace the 2 points of intersection. We want to look at this point of intersection, and we want to look at this point of intersection. So if I trace the intersection of those 2 points, this is at x equals 4.69, and this is at x equals 9.64. Again, make sure you know how to trace that. So what does that mean in terms of actual reality? You don't want to say Biggerville's growing season is from x equals 4.69 to x equals 9.64. So we know month 4. Oh, just give me a second, guys. I'm just going to pause to talk to a child. Okay, I'm back. Sorry. I'm recording again, okay, buddy? Okay, so month 4, we know would be April. And so what 4.69 of a month would be, so if we take April has 30 days, so 4.69. So 0.69 of a month is, you know, between 2/3 and 3/4. So you could take 30 and multiply it by 0.69. So that would be about April 21st. And then September, so that says 9.64. So September is the 9th month. 0.64 of a month, again, 30 days has September. September has 30 days. So 0.64 of a month. So you'd go 30 times 0.64 multiplied by 0.64, which is 19. So about April 21st to about September 19th is kind of the growing season. You could say, if this was a question on a test, you could probably say like mid-April to mid-September. Because again, that's a little bit of a precise measurement, but you wouldn't just want to necessarily say April till September, because at the beginning of April, it's probably still a little too cold. At the end of September, it's probably starting to get a little bit too cold as well. All right, we're getting close, I promise. We're not really, I'm lying. So given an equation, so in this case, we're not actually given data, but we're given the sinusoidal equation. So it says the number of gas pump attendants employed at a particular gas station in a resort town can be modeled by the function P equals 2 times the sine of 1.05 m plus 0.5 plus 5, where P is the number of people employed for the month of the year, which is m. So from the equation, we can determine lots of different things. Again, remembering your characteristics from last time. A is your amplitude, B is related to the period, C is related to a horizontal shift, and D is your midline. So what's the average number of pump attendants or gas pump attendants that are employed? So average number, we're saying something like average, think of like the word middle. And so then your midline, which is your D value. So if we look up at our equation, our D value is equal to 5. So D equals 5. So on average, over the course of the year, there's about 5 gas pump attendants working at the particular gas station. The most attendants employed at one time in any month is about blank, and the least number employed in any month is about blank. So what you need to think about is if we look at our average and then we add or subtract our amplitude, will give us our maximum and our minimum, depending on if we're adding or subtracting. So our midline again is 5, so on average there's 5 people employed. Our amplitude is related to our A value. So our amplitude, it's saying it goes 2 above or below our midline. So 2 above would be our maximum. The most, there's going to be 7 attendants working. And then if we take our average and subtract our amplitude, we would end up with 3 people is the least. So it looks like depending on what's going on during the year, there's 7 people working. At the minimum, there's 3 people working. So it says the number of people employed in October. So again, that's the 10th month of the year. So if you trace the value, again, if you put your equation into y equals, so try putting that in, and then trace the value. Trace the value at x equals 10, because October is the 10th month. It looks like in October, that's kind of their minimum number of people working, that there would be 3 people employed. So it says, how many times a year does the business in this town peak? That would kind of correlate to having lots of people employed at the gas station. Is this the same as, this is the same as asking how many times the maximum is reached in one year. So if you look over the course of 12 months, again, representing a year, how many times does your graph actually reach its maximum? So you can kind of reset your window to go between x equals like 0 and 12 and see how many times it's actually hitting the top. And what you would see is business actually peaks twice a year. So it peaks 2 times per year. And so what are the busiest and least busy months of the year? So looking at when there is kind of that maximum. So the busiest would be in, if you kind of trace where your maximums are, month 1 and month 7. So it looks like it gets busy there in January and gets busy there in July. And the slowest month, or least busy, would be when they have the least number of employees. So month 4 would be April, and we already figured out the other one would be month 10, which is October. So again, we got lots of that from the original equation, but again, you should be graphing it in your Y1 and looking at what the graph actually looks like. So you might need to modify as it goes. This lesson is getting very long, so what I might actually ask you guys to do is go look over the last one. It says example 3, given a graph, and it's looking at tidal heights, so the height of the tide for Coateville, BC. There's a problem though. You'll see that there's something missing on the x-axis. It goes, I think it goes 1, 3, 4, 5, 6, 7. So just change it to 1, 2, 3, 4, 5, 6, 7. Because there's a 2 missing, just adjust it. And then figure out the rest of those answers. Then what you can do is check my key posted under content and have a look at how I got to it. Then from there are practice questions in your notes that you need to be working on. Again, fire me an email. I'm around. Let me know how I can help you. But that's it so far for sinusoidal. So I'll send out some further instructions. Please, please, please let me know if I've made a weird mistake as we've gone. It's weird not having you guys here to correct me when I goof up. So send me an email, or if you have any other questions, I'll probably post some videos to Khan Academy as well, so you can look through how they're approaching sinusoidal function questions as well. Thanks, guys.